Let's talk about garbage collection in Java in today's lecture. To understand garbage collection in Java, let us note what is garbage in Java program. Garbage are all unused objects created by a Java program which are still in memory. In a process of making a program or while running a program, the program creates a lot of objects for one purpose or the other, another. But some of the objects are still in use, but some of the objects are unused after a while. So all the unused objects, if stacked in the memory, then the memory could be full at one stage. One stage. Okay. So all the unused objects that are still in the memory should be removed so that there could be memory for new objects that are created by the program. Removed. The process of removing these unused objects is done by garbage collector. So it is an automatic process. Garbage collector identifies the unused objects and it removes it automatically. This garbage collector and the program runs in parallel to each other. So, garbage collection aims to free the occupied memory space by objects that are no longer in use. It's a freeing of memory. Okay. So let's talk about Java memory model. Now let's talk about Java memory model. Java memory model. In Java memory model, there are Java heaps. All the objects created are stored in Java heap. Primgem, all classes and variables, class variables. And there is thread. So all the objects are kept in Java heaps. We'll talk more detail about it later. This heap space is observed by the garbage collector and then decide if the object is in unreference and they take it and throw it. All the objects that are unused is detected as unreference. All unreference objects that are detected in the Java heaps are taken away by garbage collector and throw it. So garbage collector does the process automatically, but it needs to know that if the objects are in use or not. And they identify the objects are used or not by detecting that objects are on reference. So our job for making a program suitable for garbage collector is unreferencing objects. unreferencing objects. We could do this by three processes. We'll talk about this in detail now. So the process of unreferencing an object are by nulling the reference, by assigning a reference to another, and by anonymous object. So let's take an example of by nulling an object. Suppose there are human class. So human as we create an object new human. So if we assign the object human as to null, then garbage collector will identify that this edge object is unreferenced, and it is not in use anymore. So garbage collector will remove it. The second process is by assigning a reference to another. So, for example, let's take an example of human class again. H1, we create an H1 object, new human, and we create another object as well, S2 is equal to new human. So if we assign H1 to H2, then garbage collector will identify that this H1 is under reference and it needs to be removed. It will remove it automatically. Now the another process is by anonymous object. New human dot print. So if there are no variable declared, then it will be on the reference as well. So these are the three processes of making a program such that garbage collector can remove the on the reference object, unused object. Unused objects are removed by garbage collector by detecting that objects are unreferenced. It removes all objects that are unreferenced. The process of making unreferenced objects are by nulling the reference, by assigning a reference to another, and by anonymous object. There is a term called memory leak. Memory leak. Memory leak is in Java is a situation where some objects are not used by the application anymore, but garbage collector failed to recognize them as unused. If we unreference an object, if we forget to unreference an object, then there will be a problem called memory. These are unreferenced object, a reference object. A memory leak in Java, it is a situation where garbage collector could not remove some of the object because it could not recognize that these objects are unused or under reference. In Java, we have two memory areas. These memory areas are different because Java decides where to store different data from the program depending on the use of the data. 1, 2. Java heap space. This is Java heap space is used by Java runtime to allocate memory from objects and classes that they need to load to compile and to instantiate the objects. Any objects created in the Java are any objects that are created in the Java are kept in the Java heaps, and all primitive data are kept in stack memory or reference data. The stack memory is used for execution of the main thread when you run a program in Java. If you create a variable in your execution local thread, you have a reference in the heap space, then you have to get in only the reference. The object is not in the Java stack memory. It is created in the Java heap. Only the reference here. Stack memory is always the reference in LIFO, last in, first out. Let us take an example to understand how memory interactions in Java. So as we know, there will be the stack memory and heap memory. The main method execution would be in the stack memory, and all the objects created would be in the heap memory. So let us take an example in this code. There is a class memory. It has a main method and main method with the public, and there is a foo method which is private. When the main method is executed, there are the four statements. So when the main method is executed, it creates a space in the stack memory. In the main method, the integer variable is declared first, so it makes a space in stack memory. This is the main method. So after integer is declared, there is the object created. When object is created, they are created in the heap memory. But the reference for the object would be in the stack memory. Similarly, the memory object is created, it would make a space in heap memory, and this is a reference in the main memory as well. So after that, the foo method is called. When a foo method is called, it makes a space in the stack memory for the foo method. And a param that is the object itself is passed through the foo method. This param is referenced with the. Now when a foo method is executed, it makes a space here in heap memory foo, and it is referenced with the same string object, and this string object is printed. Then after the foo method is finished. When a foo method is finished, then this space will be destroyed. Similarly, the main method execution is finished. After this, the main method execution is finished. Then the main method that is taking space in stack memory would be destroyed as well. When the stack memory is empty, deleting both the space for main methods and the foo methods, then all the objects created in the heap memory would be on referenced. all unreferenced objects are deleted by garbage collector. So when garbage collector runs, all the unreferenced objects here in the heap memory will be destroyed. By this process, all the memory in Java virtual machine will be emptied, cleared.